Right now, global technology sectors are treating artificial intelligence and distributed ledger technology as two completely parallel industries. This is a critical architectural misunderstanding. When you look at the deployment scaling of modern smart cities, you quickly realize a fundamental reality. AI cannot scale safely or efficiently inside an urban infrastructure without a decentralized blockchain backbone. The mainstream narrative is focused on consumer chatbots. But inside a cognitive city, AI is being deployed to run physical assets, autonomous transit networks, automated microgrids, and real time logistics nodes. If these automated machines must constantly rely on centralized cloud databases to verify security permissions, clear transactions, or cross reference data integrity, the system hits an absolute physical barrier, the latency wall. To build a truly automated city, we don't just need faster processing brains. We need an immutable, decentralized cryptographic spine. Welcome to the era of the autonomous ledger. To understand why this infrastructure is necessary, we must look at the shift from human to machine transactions to pure machine to machine, or M2M paradigms. In a legacy city infrastructure, a human operates the vehicle, pulls out a physical credit card, and manually settles a fee at a toll booth. The transaction relies on traditional centralized banking rails, taking anywhere from 3 seconds to 2 business days to fully clear settle accounts. Inside a smart city framework, that human element is completely abstracted out of the loop. An automated delivery pod operates independently. If that asset needs to recharge its battery array or pay a toll, it cannot wait for centralized cloud validation or traditional payment gateways. By embedding AI agents directly onto a decentralized ledger network, the machine acts as an independent economic entity. Using self-executing smart contracts, the vehicle instantly authenticates its identity to the charging station and executes a microtransaction directly on-chain. This happens in milliseconds, peer-to-peer, with zero third-party intermediaries, zero central bank delays, and zero administrative friction. Let's break down the technical engineering reason why a centralized database fails at this scale. If a city deploys 500,000 connected IoT devices, the sheer volume of concurrent data pings is unprecedented. If every device must wait for a centralized cloud response, the network congestion creates infrastructure lag. In life-critical automated systems, a 50-millisecond delay isn't just an inefficiency, it's a systemic vulnerability. Blockchain technology solves this. Instead of routing data to a remote corporate data center, the smart city operates on a distributed node architecture. Security permissions are baked into the ledger. When an AI asset requests access to a restricted municipal zone, its credentials are mathematically validated by local nodes instantly. More importantly, this architecture eliminates the catastrophic vulnerability of a single point of failure. If a central cloud monopoly goes offline, the city goes dark. But on a distributed ledger network, even if multiple nodes are compromised, the remaining network grid continues to validate and execute operations seamlessly. This framework isn't limited to transportation. Its most profound macroeconomic impact is happening within automated energy management. Traditional electrical grids are built on a centralized model. Smart cities are fundamentally shifting toward decentralized microgrids. Buildings equipped with solar arrays and localized storage facilities are transforming into prosumers, entities that both consume and produce energy. Here is where the convergence of blockchain and AI becomes highly optimized. The AI engine monitors weather patterns and predicts localized surge demands. Instead of routing that energy back to a central monopoly, the AI automatically sells the surplus power directly to an adjacent building experiencing a deficit. The transaction is cleared, settled, and recorded permanently on the blockchain ledger via an automated smart contract. The energy grid rebalances itself every second. For enterprise leaders, the takeaway is clear. Designing smart city systems using legacy, isolated technology silos is no longer viable. If you build an AI strategy without an underlying distributed ledger framework, you are building an insecure, high-latency system that will struggle to scale. AI provides the predictive logic and optimization. Blockchain provides the data, absolute integrity, cryptographic identity, and the automated settlement layer. Together, they transform the city into a living, self-sustaining software and hardware utility. This is the definitive blueprint for sovereign infrastructure. A vital question remains for leadership. Is your organization building on legacy centralized frameworks or preparing for the decentralized autonomous ledger? Let's map this out in the comments below. I want to hear your perspective on the operational challenges of M2M infrastructure. If you found this masterclass valuable, ensure you hit the subscribe button and share this with your network. Visit my YouTube channel for the detailed video. I am Dr. Usman Zafar, and I will see you in the next macro infrastructure breakdown.